दर छोट्या जिंकींसाठी अस्सल हापूस आणि रसाळ आंब्यांचा माझा होऊन जाऊ द्या.
have to replace it with. So my original
तो आज के इस वीडियो में हम लोग सॉल्व करने वाले हैं LeetCode का क्वेश्चन नंबर 205 आइसोमॉर्फिक स्ट्रिंग्स. इसका मतलब ये होता है कि जैसे हम लोग के पास अगर स्ट्रिंग है S और T नाम का, तो हम लोग S स्ट्रिंग से T स्ट्रिंग बना सकते हैं. क्या मीन्स हर एक कैरेक्टर को एक दूसरे कैरेक्टर से मैप. तो F के लिए B आ रहा है तो उसके लिए फिर से T है, फिर E के लिए L आंसर होगा. तो इसको सॉल्व करना बहुत ज़्यादा सिंपल होने वाला है. बस हम लोग को दो मैप का ज़रूरत पड़ेगा इससे इसको मैप करने के लिए, और उसके बाद उसका स्ट्रिंग ट्रू या फिर फॉल्स रिटर्न करने के लिए. तो चलते हैं और इसको कोड करते हैं. तो यहाँ पे मैं इसका कोड लिखने वाला हूँ. तो सबसे पहले मैप बना लेते हैं. मैप में कैरेक्टर से कैरेक्टर को मैच करना है तो कैरेक्टर टाइप का मैप होगा, और दोनों मैप का नाम रख लेते हैं M1 और M2. और उसके बाद सबसे पहले हम लोग चेक कर लेते हैं अगर स्ट्रिंग का लेंथ ही दोनों में डिफरेंट रहेगा तो फिर तो चेक करने का कोई मतलब ही नहीं है. तो हम लोग पहले चेक कर लेंगे कि जो हम लोग का s डॉट साइज है वो अगर नॉट इक्वल है t डॉट साइज के, मीन्स दोनों स्ट्रिंग का साइज अगर डिफरेंट है तो हम लोग रिटर्न कर देंगे फॉल्स. और फिर उसके बाद हम लोग लूप चलाएंगे पूरे स्ट्रिंग के, कर देंगे फॉल्स. और वो अगर नॉट इक्वल है t डॉट साइज के, मीन्स दोनों स्ट्रिंग का साइज अगर डिफरेंट है तो हम लोग रिटर्न कर देंगे फॉल्स. और फिर उसके बाद हम लोग लूप चलाएंगे पूरे स्ट्रिंग के लेंथ तक चलेगा, क्योंकि दोनों का सेम है तो हम लोग कोई भी स्ट्रिंग यूज कर सकते हैं. i इज इक्वल टू 0, i लेस देन s डॉट साइज ले लेता हूँ यहाँ पे, और i को इंक्रीमेंट कर देंगे. और सबसे पहले हम लोग चेक करेंगे कि इफ पहले तो S1 के लिए चेक करेंगे। अगर S1 एग्जिस्ट करता है मीन्स M1 डॉट फाइंड कर लेंगे S1 SI वाले को। यहाँ पे 1 2 कुछ भी हो सकता है, तो I जो हम लोग के लूप का कैरेक्टर है वो। फिर फाइंड करके नॉट इक्वल टू मीन्स वो एंड में नहीं होना चाहिए, मीन्स वो एग्जिस्ट अगर करता है हम लोग के मैप में। और अगर M1 का जो S ऑफ I है वो नॉट इक्वल है हम लोग के T ऑफ I से, मीन्स वो कैरेक्टर मैच नहीं कर रहा T ऑफ I, तो हम लोग रिटर्न कर देंगे। मीन्स वो जो मैप्ड कैरेक्टर है वो दूसरे वाले स्ट्रिंग के पहले कैरेक्टर या फिर जो भी ith कैरेक्टर से मैप होने के बाद भी अगर वो मैच नहीं कर रहा है तो हम लोग रिटर्न कर सकते हैं फॉल्स। यहाँ पे आप तुम 0 या 1 का भी यूज कर सकते हैं, वो भी यहाँ पे वर्क करता है। I है एग्जिस्ट अगर करता है हम लोग के मैप में। और एग्जिस्ट अगर करता है तो जो है मीन्स M1 डॉट फाइंड कर लेंगे S1 SI वाले को। यहाँ पे 1 2 कुछ भी हो सकता है, तो I जो हम लोग के लूप का कैरेक्टर है वो। फिर फाइंड करके नॉट इक्वल टू मीन्स वो एंड में नहीं होना वो को। यहाँ पे 1 2 कुछ भी हो सकता है, तो I जो हम लोग के लूप का कैरेक्टर है वो। फिर फाइंड करके नॉट इक्वल टू मीन्स वो एंड में नहीं होना चाहिए, मीन्स वो एग्जिस्ट अगर करता है हम लोग के मैप में। और अगर M1 का जो S ऑफ I है वो नॉट इक्वल है हम लोग के T ऑफ I से, मीन्स वो कैरेक्टर मैच नहीं कर रहा T ऑफ I, तो हम लोग रिटर्न कर देंगे। मीन्स वो जो मैप्ड कैरेक्टर है वो दूसरे वाले स्ट्रिंग के पहले कैरेक्टर या फिर जो भी ith कैरेक्टर से मैप होने के बाद भी अगर वो मैच नहीं कर रहा है तो हम लोग रिटर्न कर सकते हैं फॉल्स। यहाँ पे ऑप्शन 0 या 1 का भी यूज कर सकते हैं। M1 के लिए देख लिया, अब M हम लोग T ऑफ I को रॉन्ग हो चुका है। अगर हम लोग नहीं करता है तो हम लोग को मैप में एलिमेंट्स डालने पड़ेंगे। ऊपर हम लोग दोनों कंडीशन के लिए चेक कर रहे थे कि वो एग्जिस्ट करता है कि नहीं। अब एग्जिस्ट ही अगर नहीं करता तो हम लोग यहाँ पे मैप कर लेंगे T ऑफ I से, और वैसे ही M2 के लिए भी T ऑफ I को S ऑफ I से।
have to replace it with. So my original string is, you cannot add this entry over here, because think about it, no controversies were found. Then sanity checks that if the length of these two strings are different, then definitely they can never be isomorphic, right? Because you cannot add or reduce characters. So if the lengths are not same, simply return a false and you're done. Moving on, what do we do next? Next thing is we create a hash map that will map your character to the mapped character. So you will have the original character in the first column and the replacement in the second column, correct? So I get my hash map. And once I have my hash map, I will start a for loop to iterate over each character in my first string, right? So I will start with the string B and check what do I have to replace it with. So my original string is B and the replacement string is K. See this if condition very carefully now. I check if in my map I already have the original character, that is B. Right now my map is completely empty, right? So I'm just gonna add this mapping to my map. So I'm gonna say that, okay, replace B with the character K. Now you move on to the next character, that is A. So this time the original character changes to A and the replacement changes to I. Once again, you're gonna check if your map has the original key, that is A. A is not present in the map. So what do? You will simply add this to your map, right? So A gets added over here. Now move ahead and check the interesting part. You take up the character D and you have to replace it with K, correct? You come inside your if block and you check if you already have D. You do not have a D over here, right? But do you add it? No. What do? You also check if your map contains the replacement value. And what is the replacement value right now? That is K. You see that, hey, K is already present. So if the replacement value is already present, you know
Gale, hey Raj, energy. Let's go. Chal, focus.
Game on?
Game on.
Energy focus, ultimate performance. A-Rush Energy. A-Game on.
Highest paid job in 2026 is not of product manager, is not of software developer, and is not of data analyst as well. The highest
built-in popcorn says how many ones are there or how many set bits are there. So it will return 3 set bits. If this number would have been this as is I just to find here again a very important thing. Sorted, stores in a sorted time. The next thing that we will learn is priority queue. Now, as the name recommends, priority. The guy who has the largest value stays at the top. It's similar to queue, but there is something that happens inside which you learn probably after a couple of years when you are appearing for interviews. But as of now, just understand the logic, okay? We'll go right here. And this is not a linear data structure. Inside of it, a tree data structure is maintained, which you'll learn in the later half. Now, understand one thing, the data is not stored in a linear fashion, inside. Inside a tree is maintained, okay, which probably you'll learn someday, okay. So as of now, if I say pq.pop, the topmost element is popped, 10 is popped. If I say again now pq.top, where's the topmost? 8, yes. So this is how the priority queue works. Again, push, top, and pop. Main functions, the other ones are size and empty. Size and empty is very... Now the next container is very, very interesting, and that is nothing but the set container. Now what is set? Just remember one thing, it stores everything in the sorted order and stores unique. Just remember these couple of points and you know what is a set. Everything in the sorted and just unique. Just 2 points and you're done. Let's understand. So imagine this is the container, okay? And I say insert 1, so you insert 1. Imagine you say emplace 2, so you insert 2. Imagine you say insert 2, unique. So will it store 2 again? No, it does not. No, it does not. It does not store 2. If I say insert 4, will it? Yes. If I say insert 3, it will. But it will insert it here. Again, a very important thing. Sorted. Stores in a sorted order. At first, it will have 1. Then it will have 2. Then it will have 3. Then it will have 4. Everything in the sorted fashion. So it stores everything in the sorted fashion. So this is how the set will be storing. Again, a container. Is it a linear container? No, a tree is maintained. So I'm just explaining you this via this bucket. But inside of this, there is an entire tree which is maintained. Again, which you'll learn as you move forward. So insert and place works in a similar fashion. Sorted and unique. Okay. Now there are functions. If I say set.find 3 and this is the set. So it will return an iterator. Remember this. Returns an iterator which points to this 3. Which points to this 3. It returns an iterator which points to this 3. Okay. So basically this is an iterator. Remember iterator points to the address. Perfect. Now if I say set.find 6, is 6 here? No. If an element is not in the set, please hear me out properly. Points to the address, which points to this 3. It returns an iterator, which points to this 3. Okay. So basically this is an iterator. Remember iterator points to the address. Perfect. Now if I say set.find 6, is 6 here? No. If an element is not in the set, please hear me out properly. If an element is not here in the set, it will always return set.end. That means an iterator which points to right after the end. Imagine the set is having 1, 2, 4, 5 and you did set.find 3. Okay, and you don't have a 3. So you will have an iterator end. This is the iterator which points after 5. After 5. That's where dot find will return the iterator to be. It points afterwards. Okay. And after this there is set.erase. Very simple. Erases this guy 5. Erases this guy 5 out of it. Like if this is the set, it will delete 5. It will simply delete 5. You don't have to think anything. Deletes 5 and maintains the sorted order. Deletes 5 and maintains the sorted order. Now, as I said, set is nothing but unique and sorted. So if you're trying to count, if it exists, it will only have one occurrence because it does contain unique. And if it does not exist, it will have 0. So if 1 is there in the set, it will give you 1, like 1 occurrence. And if it is not, it will give you 0. As simple as that. Okay. You can also erase, like you can either give the element to be erased, like you can give the element to be erased, or you can give that, okay, this is the address or the iterator. Please go and erase this iterator. As simple as that. Now, in vector, we did learn about erase, start, comma, end. Similar thing also works over here. If you want to erase everything, yes, if you want to erase everything between 2 and 4, imagine you had something like this. So 2 is here, 4 is here. If you get the first force iterator, bracket, and this is this, everything is similar to vector. There is begin, all of these are similar to vector. So I will not be explaining them. The most important are find, count, and insert. These are the most important ones, and as well as erase. Now, they have something as a lower bound and an upper bound. So I will be linking a video in the description which explains lower bound in depth and upper bound in depth. So please go back and watch lower bound and upper bound. Once you have seen that, you will actually understand how does this lower bound and upper bound work in a set. It's the exact same that will be taught in the video which is in the description. So please make sure you watch it. Now in set, everything happens in logarithmic time complexity. If you're inserting, it takes logarithmic. If you're erasing, it takes logarithmic. Everything happens in a logarithmic time complexity. Again, if you don't know login, no issues. Please remember this in your head. Now we did learn about set, and I said sorted and unique. That means it will just contain one occurrence of 2. You can insert thousands of occurrences of 2, but it will just store one occurrence of 2. But there is something as multi-set. If you define multi-set, it only obeys sorted and it will not obey unique. It will store multiple occurrences. Like if you try to insert 1, 1, 1, stores all the occurrences. And if you try to erase 1, but all the occurrences are erased this time. But if you do an erase 1, it erases every one. And this time count will count you the number of ones in the multi-set. But if you want to delete, imagine your multi-set is containing 3 ones. And I just want to delete 1 occurrence of 1, or 2 occurrence of 1, or 3 occurrence of 1. So what I can do is, I can just find out the first occurrence of 1. So I'll just do multiset.find, because I know find points to the iterator. And I'll say erase that iterator. Instead of saying erase element, because if I say, understand, if I say erase element, it erases all the elements. But if I say erase address, it only erases that portion. It only erases that portion. And I want to erase like two ones. So I say find 1 and go till 2. Go till 2, so it will erase both of them. Both of them. So either erase element, erase address, or erase starting address and right after the end. That's it, the iterators. And rest all functions are same as set. Stores everything in the 3, 4. It can store multiple occurrences as well. So that is the depth. Something as unordered set. Everything is similar to set. The only thing that is omitted, like it stores unique. The only thing omitted is it does not stores in the sorted order. We don't know how. it will store. It has randomized order. It has randomized order. Like if I put in 1, after that I put in 5, after that I put in 2, after that I put in 3, after that I put in 6. It can have this order, it can have any order in the world, but it will just have unique elements. Like if I try to insert 1 again, it will say I have 1, I have 1. And in most of the cases, the time complexity is big-O of 1. Everything, like all the operations are same. Insert, erase, all the operations are same, but only the lower bound and upper bound function does not work. All the operations work, but the lower bound and the upper bound functions do not work. Remember this, all operations are similar to set and they do not store everything in sorted order. So all the operations are generically in a big-O of 1 constant time, but in the worst case, which happens once in a millennium, like if the data is possibly given in such a way that they want you to explore the worst case, which does not happen, then the unordered set goes for a big-O of a linear time. It goes for the worst case. Again, does not happen every day, happens once in a blue moon. The time complexity goes till big-O of n. You can just write them down in notes. You will understand these things when you move across or when you grow in experience. That's how the unordered set works. So the next container that we will be learning is a map container. Okay. Now you can think this as something like, just take a task where I say in your college, there will be there might be multiple people with Raj name, but how do you distinguish themselves? By roll numbers, right? One Raj might have a roll number of 23. The other Raj might have a roll number of 25. The other Raj might have of 28. So, this one guy is of roll number 23. The other guy is of roll number 25. The other guy is of roll number 28. So, generally, this is in your class, this is stored like this: roll number 1, roll number 2, roll number 3, and so on. If there are 50 people, you store it like this. So, map, you can think this as a data structure or a container which says the roll number is my key, and over here the value can be the name. So this is what the data structure means. You store unique keys because you can't have 23 roll numbers twice. You can have it just once. So the keys are unique. The keys are unique, but the values can be like, over here there can be a Raj, over here there can be a Raj. So there is one guy with key 3 who is Raj. There is one guy with key 50 who is Raj. There can be duplicate values, but it has to be a unique key. So you can think map as a container which stores everything in respect of key and values. And very important thing, this key can be of any data structure. It can be integer, any data type. It can be integer, it can be double, it can be pair, it can be anything. Similarly, this value can be anything. So how do you define map? This is key, this is value. Key is integer, value is integer. Over here, key is an integer, and they're saying value is 2 integers. Over here they're saying key is 2 integers and value is 1 integer. So you can define it as you wish to, that is on you. This is how you define, okay? Now, if I'm defining the map to be this, for an example, assume you're defining the map to be this. Now I say 1 equal to 2. It means on the key 1, can you please store 2? So this is what it stores internally in the map. Now, so how do you define map? This is key, this is value. Key is integer, value is integer. Over here, key is an integer, and they're saying value is 2 integers. Over here they're saying key is 2 integers and value is 1 integer. So you can define it as you wish to, that is on you. This is how you define, okay? Now, if I'm defining the map to be this, for an example, assume you're defining the map to be this. Now I say 1 equal to 2. It means on the key 1, can you please store 2? So this is what it stores internally in the map. Internally in the map, it stores 1, 2. Next I say I don't want to store it like this. Emplace 3, 1. So it stores 3 is the key and the value to 3 is 1. It does a similar thing, stores it into the map. Again, I say insert, you can also use insert. 2, 4 goes and stores 2, 4. And this is how you can store all these 3 variables. Okay, so in this way, you can actually store for this particular declaration. And remember one thing, map stores unique keys, very, very important. Map stores unique keys in sorted order, something similar to map stores unique keys in sorted order, something similar to set data structure. Map stores unique keys in sorted order, something similar to set data structure. Okay, now this is the declaration, the second declaration. For this declaration, this declaration, this is the key. So you have declared the key like this, and the value is a single integer. So this is it. For this, it will be storing like, okay, key is 2, 3. So this is stored, and the value, corresponding value is 10. Perfect. So this can be stored like this. That's how. It generically stores. Okay, I hope that makes a lot of sense. I told you that everything is stored in a sorted order. So this will at first store 1, 2, then it will store 2, 4, then it will store 3, 1. This 3 lines will be storing like this. So again, if you want to explore or if you want to iterate on the map, one of the ways is you start from begin iterator and you go until end iterator, similar in the vector. Or you do is you say it, you run a for each loop. First time it is here, so it stores in a pair. Next time it is here, it stores in a pair. Next time id is here, it stores in a pair. If it is storing in a pair, this is id.first and this is id.second. So first time prints 1 2. Next time goes here, prints 2 4. Next time goes here, prints 3 1. So if you try to do this cout, this is how you can actually traverse in a map, and everything is stored in a sorted order of key. In a sorted order of key, not value. Sorted order of key. Remember this. Sorted key is how it stores. No duplicates, all uniques. Okay. Now, if I want to access map of 1, it says a value 2. It says a value 2 because at 1 you're storing 2. But if it tries to access 5, will it find 5? There is no 5. So what happens is it says null. But if you want to print it, it actually goes and prints 0 or null. Okay, because it does not exist. So if something does not exist, it gives you 0. Okay. So this is how you can easily access for a key. Now if you want to know the iterator, imagine you want to know where the key 2 lies, the address of it. So again, the find function will come over here and say map.find3. So this is where you get it, the iterator. And in order to access this, you give a star. So this accesses this. And if you want the value, dot second. Got it? It gives you the iterator to this 3, 1. Okay, this it is this. So if you give a star, it's the element. And if you give a second, it is the 1. That's how you can easily access this as well. Now over here, if you try to do dot find 5 and 5 is not there, it points to nothing but dot end. End means after the map. Okay, makes sense? And again, the lower bound and upper bound functions, if you have seen the video in the description, you can understand how lower bound and upper bound works. Okay, and all the other functions like erase, swap, size, empty are same. So I'm not going to explain it again.
Stop before you buy this. This exact product could be cheaper on another store. And unless you compare prices, you'd never know. That's how people end up paying more for the exact same product. BuyHutK Chrome extension helps you compare prices automatically while you shop. Just hover over more options to instantly compare prices across stores. See where it's cheaper and make sure you're getting.
Next thing is multi-map, similar to map. Only thing is you can store duplicate keys. Something similar to set and multi-set, as I told you, right? Duplicate keys, but everything in the sorted order. This time you can store like 1, 2, and then you can come across and again store like 1, 3, right? So you can store duplicate keys over here. Unordered map, again, unordered map is similar. Only this portion will go across. It will not store in sorted. It will be randomized. But it will not have duplicate as well. It will just have unique keys. Unordered map will have unique keys, but it will not be sorted. And the difference is like the map sorted. It will be randomized. Duplicate keys over here. Everything in the sorted order. This time you can store like 1, 2, and then you can come across and again store like 1, 3, right? So you can store duplicate keys over here. Unordered map, again, unordered map is similar. Only this portion will go across. It will not store in sorted. It will be randomized. But it will not have duplicate as well. It will just have unique keys. Unordered map will have unique keys, but it will not be sorted. And the difference is like the map works in logarithmic of time, and the unordered map in almost all cases works in constant time In the worst case, it goes for big of n. Again, this worst case happens once in a blue moon, not always. In almost all the cases, big of 1 is what appears. So as of now, I can say that I have completed containers and iterators. Now this is not required. Not required. No need to learn it. Just omit this. Now I'll be telling you all the important algorithms, like which are mandatory, like you should know, and all the other algorithms which I will not teach. You will eventually learn while you code, but that are not, like, those are not important. So as of now, you can just leave it. Eventually with time, if it's required, learn at that moment. No need to learn it now. So let's move across to learn some algorithms. Now, if I say you that, hey, listen, I give you an array of size like 1, 5, 3, 2, okay, of size 4, and I want you to sort it. So you will be like, let's apply bubble sort, merge sort, selection sort, so and so. But in C++ STL, if you just write the line sort a comma, it's a 4 size. So this actually means the first position of the first iterator, the starting iterator, and this means the last iterator. A plus 4 actually means this portion, then portion, the last iterator. Again, similar to something like start is included and end is not included. So you write the starting iterator, which is A, which actually points to this, and A plus 4, which actually points to this. So all the elements are sorted. Right after this line, it will have 1, 2, 3, 5. So you don't have to actually use merge sort, bubble sort, selection sort. It sorts that into one line. And if you're using vector, the starting is begin. This is the ending, the starting iterator and the ending iterator. So in this way, you can sort any container, not map, all not map. I'm talking about vectors and arrays over here. Okay. Now, what if I just wanted, like, I had something like 1, 3, 2, 5, and rather, let's keep it like 5, 2. Okay. And I wanted just this portion to be sorted. So I know A plus 2 because this is A plus 2 for sure. And I know A plus 4, right after this is A plus 4. So only this portion will be sorted. So this is how only this portion will be sorted. Perfect. What if I want to sort them in descending order? Imagine you have like 1, 3, 5, and 2. I want to sort them in descending order. So it's very simple. Give the starting iterator, give the ending iterator, the portion that you want to sort, and just write greater end. Yes, just write greater end. And this is nothing but a comparator, an inbuilt comparator, which automatically sorts it, like I'll teach you comparator, automatically will sort it in the descending order like this, in a descending order. You just need to write greater end and it automatically sorts it into a descending order. Now, what if I want to sort it in some other fashion? Because as of now, we know how to sort it in increasing. We know how to sort it in decreasing. But what if I want to sort it in my way? Because going across, you will see that this my way is being used a lot. For an example, we have declared a pair array. And these are the pairs 1, 2, 2, 1, 4, 1. Okay. And I want you to sort according to second element. Like I want you to sort it in order of increasing second element. Please understand. I want you to sort it according to increasing second element. Okay. And if the second element is same, then sort according to the first element, but in decreasing. But in decreasing. What do I mean by that? So as of now, can I say the second element is 2, 1, and 1? So this 2, 1 and 4, 1 are the guys who should appear right at the first. Okay? Because the second elements are 1 and 1. And after that, I can say after that, 1, 2 will appear because of this portion. So can I say that I've sorted according to the second element? But I still have a problem. Now these couple of guys are having same second element. Now if they have the same second element, I want you to sort it according to the first element, but in descending, which means I want you to have 4, 1 at first, and then 2, 1. That means among them, I want you to sort it according to descending. So first 4, then 2. And then you can write, so first sort it according to the second. And if there is a group which is having the same second, then among them, sort it according to the first. So this is my way. This is my way. Like it's something like a combination of increasing as well as decreasing. So this is where generically you write the first iterator, the last iterator, and a comp comp. Remember this, and a comp. Now this is nothing but a self-written comparator. A self-written comparator. And this comparator is nothing but a Boolean function. Is nothing but a Boolean function. So I've written this, but I'll just teach you how to write it. It's very simple. You write Boolean comparator, and this is the function. Okay, this has to return a true and a false. This has to return a true and a false. Now go back and see what is the data type that you just had. And the data type, if you see, was pair of intent. Just copy paste and have couple of guys, pair 1 and pair 2. That's it. Have couple of guys. This is the first thing that you'll do. Have couple of guys. Now please understand this, that this is pair 1 and this is pair 2. So forget about the array. Forget about the array. And now think of just two instances where you have two pairs. Where you have two pairs. This is P1. This is P2. While writing comparator, just focus. What have you been set? Sort it according to the second element. So you say, okay, if my P1 dot second is already smaller than second, that means it's true. We are assuming that the pair 1 lies before P2. Lies before P2. That is what the assumption is. The pair 1 lies before P2. And that is okay. If the second guy is lesser than this second guy, I'm okay. They should actually. So they are in the correct order. This comparator says, are two guys in the correct order or not? And I'm saying they are in the correct order. They are in the correct order because this guy is smaller than this guy, and that is what I was said. So if they are in the correct order. But I know one thing. If it's the opposite, if this is the case, I will say they are not in the correct order. Because if I have two guys, okay, and imagine this is 5 and this is 4, and I'm saying P1 occurs before P2, this is wrong. This is wrong. If this second is actually greater than this, I know this is wrong. So I say they are not in the correct order. So what happens is comparator internally says P1 and P2 are not in the correct order. Can you please swap them? So apparently 4 comes before 5. This is what happens. So they do internal comparisons and they swap. So I told them false, they're not. So they will swap internally. But do we have any other conditions? We have. What if they are same? Because that's the only condition that is left. That is the only condition, because if these two conditions do not happen, I know we will come to a point that they are same. I don't need to write a if, because that's the only condition that is left. They are same. Now if they are same, we'll again try to evaluate. I know if they are same, this is P1 and this is P2. And this time it is descending. So if this guy is greater than this guy, it's okay. Otherwise it's not. So can I say if P1 dot first is actually greater than P2 dot first, it's okay. Because this is what I was looking for. Else I say it's not. If they're equal, it's fine. Even if I swap or do not swap, it's okay. So can I say if it's greater, it's okay. That's what I'm looking for. But if it's not, that's false. Please swap it. If it's not, I need it in descending. Can you please just swap it? So you just analyze everything whenever you try to write a comparator. Always analyze everything in terms of two pairs. Don't think in terms of arrays. Just pick up. Yes, I repeat. You just need to do one thing. Just pick up one pair. Just take another pair and try to analyze P1 and P2. That is your job. So you have learned about comparators. So anytime there is my way sorting, you can write the comparators. Just need to write this and you should be done. Just focus on the data type and try to just evaluate two data types and write it. Nothing different. Okay. So this is again one more STL which is very important, which is built-in popcorn. So if number is 7, what is the binary of 7? It's 1, 1, 1. That's the binary of 7. So as a built-in popcorn, it says, okay, this has 3 bits as 1. Generally, number 7 means 0, 0, 0, 0, 0, 0. Like these are the 32 bits inside the computer. In 32 bits, it's 0, 0, 0, 0, 0, 0 and 1, 1, 1. So built-in popcorn says how many ones are there or how many set bits are there. So it will return 3 set bits. If this number would have been 6, which is nothing but 1, 1, 0. 6 is nothing but 1, 1, 0. So built-in popcorn would have returned 2, the number of set bits. Okay. If the number is long, then built-in popcorn becomes built-in popcorn LL. built-in pop count LL if the number is long. Integer will not suffice then. Perfect. Now the last thing is, second last thing is next permutation. Now if I write a string as 1, 2, 3 and I want to have all the permutations of it, all the permutations. So what I can say is, okay, listen, I'm going to have the string and I know the next permutation is 1, 3, 2. I know the next permutation, like if I talk about dictionary order, 2, 1, 3. The next permutation is 2, 3, 1. The next is 3, 1, 2. The next is 3, 2, 1. Can I say these are the dictionary, like these are the 6 permutations that you can have. 3 factorial is 6. So if you want to print them, what you do is you first print the first string. Then you say, can you have the next permutation, please? Can you have the next permutation? And it takes you, the string which was this becomes 132. And now you print it. Again, the string now becomes 213 and you print it. Again, the string becomes 231, you print it. Again, the string becomes 312 and you print it. Again, the string becomes 321 and you print it. Right after this, it goes to null. It says no more permutations. It returns a false. If there are no more permutation, it returns a false. And if it returns a false, the while loop breaks. And this is how you can print all permutations of a string. Here's a catch. What if the string was 231? Then it would have started from 231 and the next permutation of 231 is 312 and the next is 321. So it would have just printed like first this, then this, right after this, no permutations. So it's very important that if you want to print all the permutations, you start from the sorted guy. Like you just start from the sorted guy and you can easily sort it. You know the STL now. In this fashion, you start from the sorted guy and that's how you can easily print it. Now the last one is max element. Imagine you have an array like 1, 10, 5, 6 and you want the maximum element. So if you give max element start iterator, end iterator, it gives you the address, and if you give the star, it gives you the element. Similarly, min element is also there. Right? So these are the algorithms that are generically used in DS algo in your day-to-day life. All the other algorithms are there, but they are not widely used and you will not be requiring them. So whatever STL I've taught in this video is more than enough to get started with C++. So just in case you've understood everything, it's an earnest request that get into the comment section and just write one line comment, because that is the only thing that keeps me motivated to make these kind of content. And if you're probably the first time on this channel, please do consider subscribing. Subscribing because I have a lot of content regarding trees, graphs.
तो आज के इस वीडियो में हम लोग सॉल्व करने और उसके बाद हम लोग लास्ट में एल्स कंडीशन में ये करेंगे कि और अगर ये पूरा लूप चलने के बाद भी ऐसा होता है कि हम लोग का रिटर्न नहीं हो रहा है फॉल्स, तो मीन्स वो सही है, मीन्स यहाँ पर ट्रू रिटर्न कर सकते हैं। तो इसको एक बार रन करके देख लेते हैं। तो यहाँ पे हम लोग का कोड रन हो चुका है। इसको एक बार रन करके देख, सही है, मीन्स यहाँ पर ट्रू रिटर्न कर सकते हैं।